Hi everyone, welcome to Learn with Me. This is a series which focuses on just learning for the sake of learning, exploring the different concepts in computer science without any specific course structure, without any specific objective, just doing exploration and trying to have fun on the way. So it has been some time for me since I looked at LeetCode, and I was just trying to remember and also remember all the different concepts and also maybe learn something new on the way along the way, and maybe get some of the questions answered by ChatGPT too. So this would just be for algorithms and data structures, and going forward we can also explore the different concepts in computer science. Hope you will join me on this journey. Hope you'll also have fun. So I started looking into this LeetCode 75, and looks like this has concept-wise questions which are easy and medium. So that would be interesting to just go over. There is no set objective, so we don't know whether we are going to complete this, what we are going to do going forward, but we'll just start looking into something here. So let's say I did this array problem. Now maybe hash map would be a good one. So let's just come out of that. So let's see this question. So the idea here is I'll just go over the question, try to find a solution which is brute force, try to explore a few more things on the way, and then finally we can start slowly iterating and improving it and maybe learn something on the way. So I'll try to use Java here. Okay, so find the differences of two arrays. So given two zero indexed integer arrays num1 and num2, return a list of size 2 where answer 0 is a list of all distinct integers in num1 which are not present in num2, and all distinct integers in num2 which are not present in num1. Okay, so num1 is 1, 2, 3, num2 has 2, 4, 6. So answer 0 must contain a list that says all the distinct integers here which are not in this. So 2 is there in both, 1 and 3 is not there in nums2 array, so that would be the answer here. And then here again 2 is not there, so 4 and 6 would be the answer. So that is interesting. Now when we come here, 1 is there in both, so there are repeating elements too, and there is 2 is there in both, so then the remaining number is 3. So they say here distinct integers, so we don't have to repeat 3 twice, so just say okay 3, and then here there are no numbers. So let's see, there's at least one number, and there is so the length is at least 1 to 1000, and the number itself can range from minus 1000 to 1000. So the distinct integers here are minus 1000 up to minus 1. So possible distinct integers are minus 1000 dot 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 to minus 1, 0, 1 dot 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 till 1000. So there are 1000 elements here, there are 1000 more here, and 0. So there are total of 2001 distinct numbers, but they say nums1 length and nums2 length are each can vary from 1 to 1000. So say nums1 has 1000 distinct integers which are not in nums2, then answer 0 will have the entire nums1 and answer 1 will have the entire nums2. Right, that is interesting. So what did we understand before? We know, of course, this came under the hash map um, study plan, hash map or set, but we should not directly jump into that, or rather see what is a brute force solution, right? Because what is most important is we understand the logic, and then why we are adding hash map is the next important thing. Okay, so I'll just try to add some comments here of what I'm thinking. So basically what we are manually or in a brute force approach trying to do is take each element in nums1 and go through the or iterate through, if you want to use a technical to iterate through nums2 array. If you okay, let me go to the next line. If you find it, don't add it to answer 0, else add it to answer 0. Similarly, we take each element in nums2, take each element in nums2, go through or iterate through nums1 array. If you find it, don't add it to answer 1, else you add it to answer 1. What is interesting here is, if you know that a number is, when you're searching in nums1, okay, if you take 1, so basically you're taking 1 and see, okay, is it same as 2, is it same as 4, is it same as 6? No, then you add it to answer 0. Similarly, you take 2, or is it same as 2? Yes, so then we don't add it. So then we don't have to continue 2. If you find it, don't add it to answer 0. Also stop the iteration, right? We don't continue further if you find it. And you find 3. And then you say, okay, 2, 4, 6 are not same as 3, so add 3 to the answer. And then you check, okay, is 2 there here, is 2 there here, and so on. But the thing is, we are repeating the search, right? If you find 2 already when you're searching from nums1 to nums2, what is the point of searching from nums2 to nums1 again, right? So there is a repetition here. Can we change that? So how can we stop this repetition? Let's still not try to use the hash map, though it is coming to the mind. Okay, so take each element in nums2, go through the iteration through nums1 array. If you find it, don't add it to the answer. So what if I already know what are the repeating elements? So what I'm saying is, when we are searching for nums1 array, can we also search for nums2 array, or will it become complex? So yeah, it will become complex, I guess, because let's say, I say, okay, 1, when I'm searching from 1, say 2, 4, 6. If it is not present, I'll just add 1. I cannot add any other number in nums2, right? Because I don't know whether it will come in the remaining numbers from this array. So that's not it's not very nice. There isn't a nice way to work on that repetition. So let's find a different approach. So one more thing we see is, instead of iterating, well, we don't know if the order is maintained. If the order is maintained, we might think of binary search, right? So are they saying anything about the order? So okay, there is no, oh, is there an order? This wait, No, they don't say anything about order, so I don't think I can use a binary search to make this iteration easy. What else can we do? So we see here another repetition is that 1 and 1 we don't have to check twice, right? So instead of this array was just 1 and 2, anyway in the final array, if this had 1 2 3 and this had 2 let's say 2 2 4 4 6 6, we would just add 4 and 6. So if that is the case, I am coming to the point of saying that okay, we would require a hash map or a set, rather a set. So I'm coming to the point that we will add a set instead. Before that, we can quickly see how the pseudo code, if I use this code in ChatGPT and I ask it to create, oh no, stop. So I want to say, okay, why am I doing that? Is that correct? No. Let me write the question here. I forgot the shortcut. So take each element in nums1. So given two int arrays nums1 and nums2, return list of list of answer 0 list and answer 1 list, because I've told what answer 0 and 1 here are, so I'll just remove those indices. So I'm just updating the prompt here because I forgot the shortcut. Maybe I can just search for it later. So anyway, looks like the answer might have been given earlier too. So looking at the solution here, we can clearly see that because of the two for loops, this will take a lot of time. So let's say in the inside for loop, if the second array does not have any element belonging to the first array, then this if condition and the inside for loop will go on for a long time, and for the entire second array basically, and the first for loop will go on for the entire of the first array. So if the first array contains 10 elements and second array contains 20 elements, this will take 200 into the number of seconds for one single loop, right? Similarly the second array. So if you know big O notation, it will take O of n square. If you don't know, just get familiar with that notation. We will come back to it some other time. So now let's go and start updating this logic to include set. So what we will do is the first integer array will be made into a set. That's convert is a better word. Similarly, we'll convert the second array into a set. So once we have a set, what happens is all the repeating elements will be removed right away, and it will have only the distinct elements. So because of this, we have already reduced the number if there are any duplicates. And then let's update this logic again. So for each element in nums1 set, we need to check if the nums2 set contains it or contains the element from the first set. So the contains operation in Java for a set is actually O of 1. So earlier we saw O of n square operation here. So O of 1 means, so just think that in that inside for loop, if there are n elements, this will take O of n, or rather the time required to go through the entire array, but in the set it will just take the time required to search for a single element, right? So irrespective of the number of elements in the second array, let's say it is 3 elements here, it can be 5 elements, 20 elements, 100 elements, or 1,000 or million elements, the average time required to do the search operation would just be the time required to search a single element. So that's how efficient this set operation will be, and that's why we will go for a set. So one more thing is, I'm just trying to show here what happens. Again, it is not true. So this for loop ended. So we can see that in ChatGPT. So if you see, the Java set operation is taking O of 1 average time complexity for lookups. So that is the power of a set here. Anyway, I think it is also updating the solution, but more importantly, what you see is basically this operation that braces us for denoting that it is a set. So if one is present in the set or not, this time taken is same as for one element, and it does not depend on the length of the second array, right? That's awesome. Cool. So now if we have to see in terms of the big O notations, right? If length is n can be a variable, it can be of any value, even then it will still be 1. So going forward, updating it some more for the set solution. So for each element, if the nums2 set contains nums1 set, we will add it to the answer 0. Similarly, we'll do it for answer 1. I think we'll have to make some updates. Okay. There is a mistake in prompt. I'm interested to see if this will figure it out. Anyway, though there was a mistake, looks like it figured the correct thing, but yeah. Awesome. So it's adding main and creating the set, but we need that operation to create a set, so let's ask for that. Nice. So we'll just take this set, but actually there should be a different way to create. I think it's creating the, why is it creating an array from a set? Is that what it's doing? Yeah, we don't want that. Oh wait, no, it is actually doing the right thing. Okay, so first let's create the two sets. Let's remove all these unnecessary comments. There is some formatting issue boxed. Okay, I need to see what that is. And recreate it for the second one. Let's try to format it. Why is it not getting formatted? Okay, looks like there are some extra spaces here. Yep, let's remove those. Okay, some more spaces, some more spaces. Done. So now we have created the two sets. Let's reformat and add the first and the second set proper conventions. So those two things are done. Now we will take the logic where it says about doing the contains check. Yeah, we need the results list too. So let's take that. So we have the result, we have answer 0 and 1, and that looks correct. Now we need to check nums1 set element. So for every element in nums1 set, we see if the second set contains it. If it contains, it is adding. Actually, we want to do the opposite. If it contains, we don't want to add. So we change the logic slightly. So, and then once we have added the answers, we just add it to the result list and we can return it. That looks good. So now where is the run button? Oh, there it is. So let's run it. Oh, what is the error? Line number 39. So okay, looks like one brace is missing. Let's remove this. The method is not closed, so now we can format it again and run. So the test results are looking good. I don't think we have any other cases to run here, so we can go ahead and submit. Awesome, it looks like we're beating 24% in terms of the runtime. So looks like there is still room for improvement. And let's see, the memory, it says beat 75%. Well, I thought a set was sufficient, but looks like we still have some more room for improvement because there is at least 75% more that's doing better than this. Okay, let's see. I think we'll try to figure it out in the next session. Thank you for joining. Hope you had fun.